Basically, my topic today is on greenhouse gases. So, greenhouse gas, any gas that has the property of absorbing infrared radiation, that's net heat energy, emitted from the Earth's surface and re-radiating it back to the Earth's surface, thus contributing to the greenhouse effect. Carbon dioxide, methane, and water vapor are the most important greenhouse gases. To a less extent, surface level ozone, nitrous oxides, and fluorinated gases are also the greenhouse gases. They trap infrared radiation. Greenhouse gases have a profound effect on the energy budget of the Earth system despite making up only a fraction of all atmospheric gases. Concentration of greenhouse gases have varied substantially during the Earth's history, and these variations have driven substantially climate changes at a wide range of timescales. In general, greenhouse gas concentration have been particularly high during warm period and low during the cold period. That simply implies that when the atmospheric temperature is high, there is tendency for high concentration of greenhouse gases. When the atmospheric temperature is low, there is low concentration of greenhouse gases. So there are a lot of processes that affect the greenhouse concentration. A number of processes influence greenhouse gas concentrations. Some, such as tectonic activities, operate at timescales of millions of years, whereas others, such as vegetation, soil, wetland, and ocean sources and sink, operate at timescales of hundreds and to thousands of years. Human activities, especially fossil fuel combustion since the Industrial Revolution, are responsible for steady increases in atmospheric concentrations of various greenhouse gases, especially carbon dioxide, methane, ozone, and chlorofluoride carbons, that is the CFCs that destroy the ozone layer. So these are some of the greenhouse gases in the atmosphere, but basically we're going to talk about water vapor as greenhouse gas, as one of the greenhouse gases. So we will look at water vapor objectively and expatiate on how it affects the global warming on Earth, and how its concentration has contributed to the climatic changes and the global warming, as we have said in general. So, but before we go into that, well, I want to really emphasize on what the UN, United Nations Organization, have said about greenhouse gases, how they have defined and what they have said concerning the greenhouse gases. The effect of each greenhouse gas on Earth's climate depends on the chemical nature and its relative concentration in the atmosphere. Some gases have a high capacity for absorbing infrared radiation and or occur in significant quantities, whereas others have considerable lower capacity for absorption or occur only in trace amounts. Radiative forcing by the UN, an organization formed by UN, United Nations, as defined by, they said radiative forcing as defined by the Intergovernmental Panel on Climate Changes, that is IPCC, formed by United Nations in 1988. It said it is a measure of the influence a given greenhouse gas or other climatic factors such as solar irradiance or albedo. That is radiative forcing. That's the definition of radiative forcing. I repeat again, as defined by the International Panel on Climate Change, IPCC, is a measure of the influence a given greenhouse gas or other climatic factor such as solar irradiance or albedo has on the amount of radiant energy impinging upon the Earth's surface. To understand the relative influence of each greenhouse gas, so-called forcing value given in watts per square meter calculated for the period of time, you see, so you can equally measure the effect of greenhouse gas on the atmosphere. So, but today we are not going to do the calculation and the measurement of the effect of the greenhouse gas in the atmosphere. So we want to concentrate on a particular greenhouse gas called the water vapor. It's a very common thing. You know, water exists in three different forms. Water exists in the solid, it exists in the liquid, it exists in the gaseous state. Today we're going to talk about water and gaseous stage, which is the water vapor. So basically, before we talk about this water vapor, we want to understand where do we find water, you know, in common. We find water in the ocean, which is the hydrosphere. We find water equally in the biosphere where the organisms live, including human and plants, all living things. We find water equally in geosphere, that is the lithosphere. We equally find water in the atmosphere. So this water we find in the atmosphere is classified as water vapor. This is the one we want to talk about. We want to talk water in the gaseous state. So water vapor is the most potent greenhouse gas in Earth's atmosphere, but its behavior is fundamentally different from that of the other greenhouse gases. The primary role of water vapor is not a direct agent of radiative forcing, but rather a climatic feedback. What do I mean that water vapor is a climatic feedback? That it simply means when there is high intensity of heat energy, when there is infrared that is directed to the earth, the infrared absorbs the water from the surface of the earth. That is from the hydrosphere, it absorbs it from the green plants, that is from the biosphere, where, you know, through the process of photosynthesis, you absorb it in the lithosphere, from the soil to the atmosphere, where it condenses. The process in which this water is absorbed in the surface of the earth is called evaporation. The water evaporates through air. You know, air is mixture of various gases, and it's condensed in the atmosphere. The warmer the atmospheric temperature, the high concentration of water vapor in the atmosphere. So basically, the water vapor is not radiative forcing. It's not a radiative forcing. Rather, it is a climatic feedback because it absorbs the water from the Earth's surface and to the atmosphere and redirect it back to the surface of the earth. So it is like a cyclic movement. The water, this process happens. It absorbs water. The infrared, the radiant energy absorb the water from the atmosphere, from the biosphere, from the hydrosphere, from the lithosphere, and back to the atmosphere. And the vapor contains there and redirect this energy, this radiant energy back to the surface of the earth. That is why it is called the climatic feedback. That is as a response within the climatic system that influences the system's continuous activity. The distinction arises because the amount of water vapor in the air temperatures. So this distinction arises because of the amount of air, amount of water concentration in the atmosphere. So it is the higher the concentration of the water, the higher the temperature becomes, because the radiant energy will hit the water vapor in the atmosphere, and it will redirect. The more the absorption of this heat, the more it will redirect it back to the earth. So that is as a response within the climatic system that influence the system's continuous activity. This distinction arises because the amount of water vapor in the atmosphere cannot, in general, be directly modified by human behavior, but instead set by air temperature, as I've rightly said. You see, what the amount of the water in the atmosphere is not in any form controlled by human behavior. It's not our behavior, it's not our activities that control the water vapor in the atmosphere. I want to give you an instance. We cannot control the evaporation of water in the ocean. We cannot control the evaporation of water in on the leaf of green plants. You can imagine the ecosystem. Imagine the leaves of the green plants when there is high intensity of heat during the day, during evaporation, during photosynthesis. The water will evaporate from the leaves of the green plants. We cannot control. These are processes these are natural phenomena that we cannot control. These are natural phenomena that we cannot control. We cannot control the evaporation of water in the ocean, in the lake, in the river. We cannot control the water evaporation on the land. These are things that the nature have put in place to ensure that the water evaporates to the atmosphere. So equally, it's during the photosynthesis, it's not only water that evaporates, even oxygen, because oxygen and they evaporate to the atmosphere. The water equally evaporate to the atmosphere. These are a chemical breakdown of the substances that are found in green plant. So when these processes occur, the water evaporates to the atmosphere. So basically, we're talking that the evaporation to the atmosphere, the water vapor evaporating in the atmosphere is not human. It cannot be controlled by human behavior, but it is instead set by air temperature, the atmospheric temperature. The warmer the surface, the greater the evaporation rate of water from the surface. As a result, increased evaporation leads to a greater concentration of water vapor in the lower atmosphere, capable of absorbing infrared radiation and emitting it back to the surface area of the earth. To the surface area of the earth. So I've made myself very clear. You have understood what I mean by evaporation of water vapor and how it contributes to the greenhouse effect. So the higher concentration of water vapor in the atmosphere based on temperature variation, based on the atmospheric condition, when the weather is warm, when there is high temperature, there is tendency for higher evaporation. When the water evaporates to the atmosphere, there is higher concentration in the lower part of the atmosphere. And when there is high concentration of the water vapor in the atmosphere, the heat energy, that is the infrared radiation, hits the water vapor, and the water vapor redirects it back to the earth, so causing global warming, causing climate change, and equally, which we call the global warming. The whole globe will get heated, the temperature will increase as a result of these processes that are taking place by the greenhouse gases. So next topic, we are going to talk about carbon dioxide. We're going to talk which is the fossil fuel, how it affects human activities, how it affects the atmosphere, how it affects the earth, how we'll talk about the fossil fuel and all the properties of the carbon dioxide, and how the carbon dioxide react with other chemical substances, other elements in the atmosphere, and they cause harm to the atmosphere, especially to the ozone layer, and damage the ozone, pollute the atmosphere. These are the areas we are going to concentrate in the next topic. Thank you for listening.